Got it. We've still got to do derivatives as part of that. That's going to be like 4 weeks on its own. There's some topics in here like this I'm moving through fairly quickly because it's mostly it's not too complicated. The stuff we're doing now is where it starts to get like you really need to stop and think about what you're doing. No, I'm just going to throw you into the exam without any practice. No, of course we will. Of course we will. There we go. Okay. So, obviously, guys, last lesson we plotted some stuff in GeoGebra. Um, we of course need to be able to do things in a tech-free exam. So we need to be able to plot these trig equations outside of technology. So we're going to plot these by hand. Now, that sounds really, really annoying, and it is in a lot of ways. Um, I don't know that I'd say it's easy. It's a lot of work. The way I do it at least is a lot of work, but it makes sure you get the right answer at the end. I basically do one thing at a time, and do it that way. Okay. So I'm gonna draw a set of axes over here. They're gonna go from 0 to 1 to -1. And now students, for whatever reason, this blows their mind. This is the way you want to draw your axes for a regular. We're going to do sine theta here. So this is y equals sine theta. How long does it take sine theta to repeat? To repeat the pattern. It repeats for infinity, but how long does it take to do a full circle? Which is how many radians? 2 pi. So what I do, guys, the end of my graph, 2 pi. Halfway, pi. Between 0 and pi, halfway would be half of pi, pi on 2. And halfway between pi and 2 pi, if we're counting in pi on 2s, pi on 2, 2 pi on 2, 3 pi on 2. 3 pi on 2. So that, in other words, is 0, 90, 180, 270, 360, every 90 degrees. Now, if we think about our unit circle, guys, at 0 degrees, what's the height of my point at 0 degrees? 0. And sine measures the height of the triangle that the unit circle makes. So at sine of 0 degrees is what height? 0. So our first known point is here. At 90 degrees, what's the height of my triangle? And therefore the height of sine theta. The value of sine theta, I should say. Well, it's the unit circle. So how long is the radius of the circle in the unit circle? Just one. Just one. So if we're at the very top of that circle at 90 degrees, what's our y coordinate at the top of the circle? 1. So at sine theta, if theta equals pi on 2, I'm at positive 1. At 180 degrees, guys. 180 degrees? Not 0. You've jumped the gun a little bit, but then when we go down to 270 degrees, whoops, I didn't mean to erase that. When we're down here at 270, what's my height of my -1? And then when I get back around to 360 degrees or 0 degrees, what's my sine value gone back to? 0. So can you see that I've just drawn a sine curve?
So what's that value?
3 pi on 2. Oh, It's one thing after another today. Okay. So, guys, do you feel comfortable with what I've told you? That is the graph of sine theta. Yeah, that's what happens to our point as we go around the unit circle. Okay. What does this have to do with our question? Plot y equals 3 sine 2x plus 2. Well, all y equals 3 sine 2x plus 2 is we're taking a sine curve and we're stretching it, we're pulling it, we're moving it up and we're moving it around. Does that make sense? So we're going to start with this sine curve every time, and we're just going to do different things to it until we get it to being the same as that question over there. Clarice, was that a question? Yeah, so cos is the same, except it starts at 1, and then it goes to 0, and then -1, and then 0, and then back up to 1. So it would just be shifted to the left a little. Okay. Guys, what transform do we want to do first? Do we want to add in our A value? Do we want to add in our B value? And this one at the end, is that our C value? No, that's our D value. There's actually no C value in this question, which makes it a little bit easier. C is the most painful one to do, I'll just warn you now, which is why I've started out without it. Which value do we want to add in first, guys? A? Cool. What does A do to my function? Vertical stretch. What's the amplitude of my sine y equals sine 0? Yeah, you're jumping ahead. This one here, what's its amplitude? The one that I just drew. Yes. Yeah, so I keep forgetting that it's so tiny. But the y equals sine theta, it has an amplitude of 1. And you can see that from the median value at the moment is 0. It goes 1 above, 1 below. When we change our amplitude to 3, what's going to happen? 3 above, 3 below. Are our critical points going to change otherwise? Is it still going to be 0 at the beginning? What's going to change with this pi on 2, 1 coordinate? Yeah, it's still going to be happening at pi on 2, but it's going to happen 3 times as high. What about this one here, pi and 0? What's going to happen there? This one here. It's just going to be 0 again. This one, and then that one. Cool, let's draw it. So this time, all we're doing is we're including that A value, 3 sine theta. Exact same sine curve, but we're just adding in that amplitude of 3. So we agreed that we're starting at 0 still, but then at pi on 2, we're not at 1 anymore, we're at 3. Then back to 0, -3, 0. So I've drawn those graphs the same, but the axes are different on each one. So the bottom one is stretching 3 times as far away. What some people like to do, and I might do this on the next one, I'll just do one big set of axes, but I'll color code the different, and I'll draw them all on the same set of axes and color code them. Some people prefer doing it that way. Sine theta, because I'm starting with y equals sine theta, which is what I know. And I'm just going to add one of those changes, so the A, B, and D value in at a time until I get to the final form. So we're just doing one step at a time. Once you get a bit more confident with this, for instance, I do A and D at the same time. Like I just do that in one step because it's pretty easy. But for these first ones, we're going to do it one at a time until we're feeling a bit more confident. Well, we're going to add one of them in next. Which one do you want to add in next, Kurt? B?
Yeah, 1. 0 to pi, you have 1, you'd have 2 when you have 2x. B value of 2, you do 2 at the same time.
Yeah. You know how sometimes, like, someone's speaking perfect English at you and your brain is just, like, spinning its gears? And it's like, I understand all those words, but I'm not putting it together. So we're going to have the same axes for this one, guys. But this time our rule is going to be y equals 3 sine 2 theta. Okay. Now, Cody is correct. We're basically going to do 2 full revolutions instead of 1 full revolution. Mathematically, what we're going to do, though, guys, is we will calculate the period. So does anyone remember what my rule for the period is? That's it. So over here, I might just write all of them out. My amplitude is 3. My vertical shift is 2. And my period is 2 pi on b, which is 2 pi on 2, which is pi. Okay. What that means, guys, our function was repeating in this distance, 2 pi. It's now halving, so we're condensing it down into half the space. So is my function still going to start at 0, 0? So I'm condensing it. So it's still going to start at 0, 0. Is my first critical point going to be at pi on 2, though? It'll be occurring twice as quickly as it was before. So it'll be half that distance. What's half of pi on 2? Pi on 4. So my first non-zero critical point will be there. Now, previously, the next time I got back down to 0 was at pi. But we're going twice as fast this time. We're going through 2 full cycles instead of 1. So if I'm going twice as fast, instead of getting there at pi, where's the next critical point going to be? Pi on 2, that's right. Now, instead of, our next critical point was 3 pi on 2, but we're going twice as fast, so we're getting there in half the time. Instead of 3 pi on 2, where's my next critical point? What's half of 3 pi on 2? 3 pi on 4, that's right. It's always funny watching you guys when you're first getting your head around using fractions so much. To find half a fraction, you double the bottom. It sort of works opposite than you intuitively think. So half of 3 pi on 2 is 3 pi on 4, because you're dividing it by half again. So my next point would be here, 3 pi on 4. And at 3 pi on 4, what's happening to my function? Is it at a peak, a trough, or a midpoint? Trough. Where's my next critical point going to be, guys? Pi.
So why we have to write 3 pi, right?
I just like to label where the critical points are happening. There is underneath it. There's a trough underneath it. Basically, can you see along the bottom, we go 0, pi on 4, pi on 2, 3 pi on 4, pi. The next one's going to be 5 pi on 4, then 6 pi on 4, 7 pi on 4. So 5 pi on 4. Okay, even I can't read that, I apologize. 5 pi on 4. Yeah, good call. And then halfway along would be 7 pi on 4. That is really small. I do apologize, guys. we've done one loop already, guys. Is the pattern going to change? No, we're at a midpoint. It's going to go peak, midpoint, trough, midpoint. So let's draw them in. Peak, midpoint, trough, midpoint. And we're up to 2 pi. And if we look back to our question, it asked us to plot it from 0 to 2 pi. So I don't need to keep going. So let's just draw in our function then. Now, it's very important, guys, to realize that the question did ask us to sketch. I don't care how artistic it is, how neat it is. I care that you have the points happening in the right spot, which is why I like to label them, so it's very clear what's happening where. So it goes pi on 4, pi on 2, 3 pi on 4, pi, 5 pi on 4, 3 pi on 2, 7 pi on 4, 2 pi. Now, you could, if you wanted, instead of using those labels, you could have said 0, pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4, 7 pi on 4, 8 pi on 4. The reason we don't do that is because we like to use our simplest fractions. There is, however, nothing wrong with doing it that way. If that makes it a bit clearer in your head, okay, we're having a critical point every pi on 4 radians. If we had a b value of 3, they get really annoying when you have a b value of 3 because you end up having a critical point every pi on 3 radians. Sorry, every 2 pi on 3 radians. No, what? Yeah, 2 pi on 3 radians, which is a real pain in the butt. I don't like those ones.
So, how do you say 3 sine 2 theta?
Mm-hmm.
How does the 2 determine how close they are?
Okay, so
How did we look at that and say, okay, we've got to draw this?
So there's a few ways we can sort of talk about that, right? We've got our rule for the period, where the period is just 2 pi divided by whatever your b is. Now our b value is 2, so it just becomes 2 pi and 2, so pi. So that means this particular function completes a full cycle after pi radians.
So
the other way to think about it is we're basically fast forwarding at 2 times speed. So instead of having a critical point every pi on 2 radians, we're having them twice as quickly. So the distance the function has to travel is being halved, essentially. We're going 2 times as fast.
So plus 2.
Yeah, this last one's actually going to be probably the easiest. We're just going to shift every point up 2. Okay, I'm going to draw this last one nice and big. Actually, hold up. Hold the phone. Do it like this. 0. For the last one, guys, we're plussing 2 as our d value. So that's a vertical shift of 2. What does a vertical shift of 2 mean? Yeah, we just take every critical point and we grab it and move it 2 up. So it's going to be the exact same as above, but just 2 higher. So our... Not quite, because our lowest point was -3. What's it going to be instead? -1. Our highest point was 3. What's it going to be instead? 5. So if we've got -1, 1, 2, 3, 4, 5, where's the median value of my function going to be? So before the median value was right on the x-axis at y equals 0, but we have a median shift of 2 now. So it's going to be up at 2. So I'm just going to, at 2, guys, I'm just going to do a dotted line across just to remind myself that this is the new center line of my function. Okay. Similar as before, I'm just going to write in my critical points. Cody? If you did what I did and you had a solid line at 2, as long as it was labeled that way, I'd be fine with it. Your y-axis doesn't have to, you don't have to draw it on the Cartesian plane. I like to do it this way. It just helps me keep track myself, but how you do it's up to you. So over here, we're going to have the 2 pi. Halfway along would be pi. Halfway along, pi on 2. Halfway along here, 3 pi on 2. But then because we have that b value of 2, our period has been halved. We get through everything twice as quickly. We're going to need the intervening coordinates as well. And we're going up in pi on 4s. Pi on 4, 2 pi on 4. So previously, for a regular sine curve, we go up in pi on 2s. But because we're going through it twice as quickly, we're basically halving everything. So we take pi on 2 and we divide it by 2, which gives us pi on 4. If our b value was 4, we'd be taking pi on 4 and dividing it by 4 instead. Whatever the b value is, divide your first critical point by that, and that tells you what you need to do. 3 pi on 4, then pi would be 4 pi on 4, 5 pi on 4, 6 pi on 4, 7 pi on 4. Do you see what I mean the other day when I said you're going to get very used to using these fractions? Like, they're just in every question. You've got to, like, sort of get your head around using them. Clarice? Because originally the center of our function was sitting on the x-axis, but we've vertically shifted it too. So the dotted line, that's just where I'm going to put the, like, median values. So, like, previously we started at 0, now we're going to be starting at 2, so it's just going to be on that dotted line. It's just to help me keep my diagram neat, essentially, that's all. My next critical point, all we've done is shifted it up 2. Instead of being at 3, it's going to be at positive 5. Back down. Jeez, that is so crooked. It's embarrassing. And then, so median point, peak, median point, what's next in the pattern? Trough. So at 3 pi on 4, there's a trough at negative 1. At pi, there's a median point. At 5 pi on 4, there's a peak. At 5. 3 pi on 2, there's a trough. 7 pi on 4, there's a trough. 2 pi, there's a median value. Draw them together. Can you see what I mean, guys? None of that was difficult. It just took a while. We just went step by step. Do you see what I mean as well, where, like, it's really easy to combine the A and the D step, where you just move the median value and then you shift up or down from that? It's not too hard to do at all. I like to do it that way. I find it easy to do those two at once. Otherwise, you spend forever on one of these problems. Cody?
Like an example, so instead of that, you can do the one.
You can do the final one straight away. In an exam, I'd expect to see, so especially if there's a phase shift in it as well, just what I was doing over here, amplitude, vertical shift, period, phase shift. From that, you can generate all your points. This way, it's a lot easier to see how everything is working, though. Who feels like they're understanding how to do this? Yeah. Sick. Got, like, wood putty on my hands. Okay. Before we go on to the next page, questions, comments, concerns? Yeah. You may.
How'd you go? Exactly.
You didn't notice I was making eye contact the entire time I was drinking it. Oh, sorry, the recording's going. I'm not drinking anything I shouldn't be in the classroom. Where'd that come from? Cody must have given it to me.
That the X values are set pi 4, pi 2.
Yep.
Will they always stay the same?
They will depend on your B value. So I think in the next question we have a different B value. Yeah, we've got 3. So the next one's a pain. But the next one, they will be different. Okay. Hold up. That's all. Cool. Okay. Similar thing, guys. Plot the following function from 0 to 2 pi. 0 to 2 pi. Before we do our axes, let's just figure out our vertical shift, amplitude, period, all that stuff. So can anyone call out what's one of the easy ones that we can straight away just read off from the equation? Amplitude. Amplitude is 4. Too easy. What else? Yep. Vs. What's that? -2. What do we want to do next? Period or phase shift? Period. Period is, what's my rule? 2 pi over b. And what's my b value in this case? 3. 2 pi on 3. What's 2 pi on 3? Clarice?
So how many?
Yes, that's right. What's pi on 3 in terms of degrees? 60, so 2 pi on 3 is 120.
You can't think of this.
Sorry? Almost. So what that means is every 120 degrees, this function repeats itself. So how many loops of the full function are we going to have over 2 pi radians? So in 2 pi, sine theta over 2 pi repeats once. So I have a b value of 3, so how many times is it going to repeat? 3. It's going to repeat itself every 120 degrees or every 2 pi on 3 radians. Okay? We also are going to have phase shift in this one. I hate phase shift a lot. It is what it is. Anyway, so my phase shift. Can anyone remember the rule for phase shift? 2 pi on 3. -c over b. Now, looking at the question, is my function going to shift to the right or to the left?
It's a negative.
It's negative, so it's going to be to the right. Our rule for phase shift corrects for that. So we're going to get a positive or a negative answer for our phase shift. Phase shift. Positive. Now, that means shift to the right. A positive phase shift is a shift to the right. A negative phase shift is a shift to the left. Okay. I'm going to show you a separate way you can solve these ones as well. I don't know if it'll help or not, but hopefully it will. Okay, but we still need to solve this. So what's our C value? -pi on 4. That's important. Don't forget the negative. So negative. Now, I generally put C in a set of brackets just so I can remember that there's going to be a double negative there that I'll have to deal with. Divided by my B value, which was 3. Because there's a negative in our C value happens to be negative for this problem, and there's a negative in the rule. So that gives us just pi on 4 divided by 3. Pi on 4 divided by 3, pi over 12. Remember, if you need to find a third of a fraction, times the bottom by 3. Can anyone tell me what's pi on 12 as a degree? What's pi on 6? Yeah, pi on 6 is 30, so pi on 12 would be 15, half of pi on 6. You may notice, guys, I keep on relating everything back to degrees. Even though we're working in radians, and I do this in my own head as well, we're conditioned to think in degrees. There's nothing wrong with thinking in degrees, but you need to be confident in what degree matches to what radian. The only ones you really need to remember is pi on 2 is 90, pi on 3 is 60, pi on 4 is 45, pi on 6 is 30. If you can remember those four, you're good to go. And everything else you can just work out from there. Okay. Okay, I'm going to show you the other way you can do these ones first. The other ways you can do this one first. Okay. So I just put a little bubble around those. So sine theta has, you know how before I was talking about the peak, the trough, the midpoints? We call those critical points. Where does sine theta have its critical points? 0, 0? Where else? So that if we go back to our previous page, if we look at our sine theta graph, we had 0, 0, then we had pi on 2, 1, pi 0, so on and so forth.
Is this easier way?
It's a different way. It's not necessarily easier or harder. It just depends on what you find easy. I'm just showing you both so you can choose which way you want to solve them. After it gets up to the peak at 1, it goes back down to the midpoint at pi. And then we have a trough at 3 pi on 2. And then we go back to the midpoint at 2 pi, comma 0. Are you all happy with representing it as critical points instead of the graph? Does that make sense? Do you see what I'm doing? Okay. If I took into account the amplitude, let's do the phase shift first. Not phase shift, vertical shift. So if I took into account sine, and what are we, minus 2? If this is now my equation, sine theta equals minus 2, what happens to the critical points that I've just written there? Everything gets moved down 2. So are my x-coordinates going to be affected at all? No. I'm just going to take 2 off every one of those values. Okay. So that's going to be 0, comma, negative 2, pi on 2, comma, negative 1, pi, comma, negative 2, 3 pi on 2, comma, negative 1, 2 pi, comma, negative 2. I've done something very silly here. Should be negative 3, yeah. Okay, thanks, guys. Apparently my eraser is like, not today, buddy. Story of my... Okay, this is gonna be a 3. Okay, let's do amplitude. Like I said, you can do this in one step. Just for this one, I'll show you separately. If I then make that, what was my amplitude, 4?
Negative 2.
My amplitude is 4. Where are my midpoints going to be? Are they going to change? Well, the midpoint, is the midpoint going to change based on the amplitude? So all those -2s are going to stay the same. What's going to happen to my peaks, though? Instead of being at -1, where are they going to be? They're going to be further up, that's right. How far? 4 up. So instead of starting at median point -2 and going up 1 to -1, they're going to go up 4 to +2. Then my troughs, they're starting at -2. They're going 4 down. What are they going to get to? -6. So it'll be the exact same thing again. Midpoints, unchanged. Peaks at +2. Troughs, -6. 2, comma, pi, comma, -6. Oh, sorry, that should still be -2, shouldn't it? Comma, a trough now at -6.
So for the pi on 2, 2, that being 3 is bringing up.
Pi on 2, 2. Oh, sorry, yeah, it would be. No, because we're starting at -2, and we're going down 4. 3, 4, 5, 6. Yeah, okay, no, yeah, you guys. Yes. Yeah, it would. Why is it?
It would be this.
What I've written there is correct. I kind of did this in the wrong order. Normally, you do the amplitude first and then you vertically shift it. It's a little bit easier to follow that way. Okay, if we look up here, can you see in this first one we change the amplitude between these two? The midpoints don't move because the A value, all it tells you is how far away from the midpoint you go. So if you're at the midpoint, you don't change. That's right. Okay. Now, I'm going to do a brief little aside here. With a B value of 3, with a B value of 3, with a B value of 3, that means we take all of our existing X values and we want to find what 1/3 of it is. Because how long does it take for our whole period to repeat? Not 2 pi, 2 pi on 3. So everything, we just divide each one of these X values by 3. So that means 4 sine bracket 3 theta minus 2. When you divide 0 by 3, what do you get? 0, that's right. When you divide pi on 2 by 3, what do you get? When you divide pi on 2 by 3, what do you get? Pi on 6. When I divide pi by 3, what do I get? Pi on 3. When I divide 3 pi on 2 by 3, what do I get? That is correct. When I divide 2 pi by 3, what do I get? 2 pi on 3, that's it. One step to go, and it's the most annoying one. Yep.
356 is 352.
Yep. I'm not going to do that though. And here's why. Phase shift is a pain, and it's easier to work in higher bases than lower bases. Yeah, this last step is the most painful. So what was our phase shift again? Pi on 12. Now, everything's being shifted 1 to the right, correct? Oh, sorry, pi on 12 to the right, I should say. So we're going to have to each our x values, what we're essentially doing is adding pi on 12 radians to it. Do any of those x values look like it's going to be fun to add pi on 12 to them? No. Why is it not going to be fun to do that? Because math, essentially, what's the annoying thing about adding fractions? The bases have to be the same. So before I go to do this next step, I want them to all have the same base. And what base would we want them to be in if we're adding pi on 12 to it? Pi on 12. So let's do that. So I'm just going to make a note. Swap to pi on 12 measurements. So what's 0? Well, it's just going to be 0, isn't it? That's easy. 0, comma, -2. If I was to turn pi on 6 into pi on 12, what else would I have to do? The bottom becomes 12. What would the top become? 2 pi on 12. Are we all right with that idea? Pi on 6. I might show you on the board. If I start, let's start with 2 pi on 12 and work backwards. Is there a common factor top and bottom? 2. 2. So if we take a factor of 2 there, a factor of 2 there, we're left with 6, like I say. Pi on 6. Now, so I can then work back and say, well, if I want to make this pi on 12, I just need to double the bottom. If I double the bottom, I need to double the top. So,
Why are we doing this?
in a second, we're going to have to add pi on 12 to all of our numbers. And it makes it so much easier if our fractions are already on 12, because then we just add the tops together. We don't need to worry about anything else. You'd be surprised. This one, but the way I'm doing it is very long, just for this example. But this way can actually be way quicker. And once we get to the actual graph at the end, you'll see it can be quite quick. If I wanted to make it over 24, what would I do to top and bottom? Times that by 2 again, so it would be 4 pi over 24. That's all we're going to be doing here.
The next one would be.
So next one we've got pi on 3. What do I need to do to 3 to turn it into 12? So it would be 4 pi on 12. Can you see a pattern? We've gone from 2 pi on 12 to 4 pi on 12. Anyone want to guess what the next one's going to be? There you go. This is the good thing about this. It's because it's a pattern, it goes up by the same amount each time. Comma -2, comma 6 pi on 12, comma -6, comma 8 pi on 12. -2. Now, for phase shift, we just got to add that to our x values. So this is giving us the rule 4 sine 3 theta minus pi on, what was it? Pi on 4. minus 2. So instead of starting at 0, what's it going to start at? If we're adding pi on 12 to it, what's 0 plus pi on 12? Zero plus pi on 12. Pi on 12. If I add pi on 12 to 2 pi on 12, what do I get? 3 pi on 12. I'll answer Ryland's question then, Zoe's. What I'm doing is I'm accounting for the phase shift. So we know for our phase shift is pi on 4, right? Oh, pi on 12, sorry. Pi on 12. So that means every one of our x values is being shifted to the right by pi on 12. Mathematically, what's happening is we're adding pi on 12 to every one of our x values. So you can see here, we started at 0 as our first x value, but we've been phase shifted pi on 12 to the right. So I'm just adding pi on 12 to 0, which gets me pi on 12. Well, it's not because our phase shift is positive.
Phase shift is positive, it's right.
Correct. So 3 pi on 12, comma 2. Oh, Zoe, you understand it now? When we add pi on 12 to 4 pi on 12, what do we get? 5 pi on 12. You learn to love pi on fractions with pi on them. You're going to get used to them, I hope. Like I said, normally you would do like the phase shift and the median value together. Like this is like 2 or 3 times the amount of working you'd normally do, but it's just to help you understand how it all works. We're gonna have some fun now, guys, and we're gonna plot it. I'm gonna leave that up, yeah. We're plotting from 0 to 2 pi. The question asks us to plot from 0 to 2. So we've got to plot from 0 to 2 pi. But those critical points there, what they represent one full rotation. Do we need to really figure out the rest of it, or can we just continue the pattern once we've got one full rotation? Just pattern it away. So the good thing about maths is like if you know something has a pattern, there's no need to like repeat working out. Sorry? Up a smidge. So for this, guys, I know my median value is -2. My peak is 4. My trough is -6. Okay. What? You know, you make a good point. It is. My bad. I am also fried in the brain today. Okay. Now, we know we want to go up until 2 pi at the end here. Now, I'm not going to mark I'm going to put my markings in. Normally, we'd have a critical point halfway along at pi, right? And we'd have a critical point halfway between there and there as well. Those are our normal critical points. how many critical points are we going to have instead of those ones? Like, we're going to have how many times as many, basically. We're doing 3 rotations, so there's going to be 3 times as many. So, not necessarily. I'll explain the way I do this. What are we counting up in? Pi on 12. Where is pi on my number line there? Halfway, pi. What I'm going to do, guys, I'm just going to split that first bit into 12 sections. It's already been split into half. So how many sections need to go in each of those halves there? 6. So I'll split it into half again at the beginning, and then split each of those into 3. And if my maths is right, 1, 2, 3, 4, 5, 6. Make sense, guys?
Yeah.
So this would be pi on 12.
We do that around along the whole way.
Yeah. So split the section into half, and then half again, and each of those has hold up. I've done a silly here. Don't listen to me. Yeah, so that is not halfway. Ah. That is not halfway. What was I doing? I mean, you're right, but I just don't understand why my eraser isn't working. There it is. Okay. So, there needs to be 12 increments from 0 to pi, because we're doing pi on 12. Cody? Yeah, I think yeah. The first half I had correct. I just got into my own head. Yeah, so halfway is 6. So we just need to split that up into 6 equal parts now. So halfway is 3, so split that into 3 equal parts. That into 3 equal parts. Same thing there. 3 equal parts. 3 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool.
You said it's easier to see your critical points when there's like directly below it. It says exactly what it is.
Yeah.
Like you can't just sit in between. Is that right? Like if it was on a test and it had 2.
Yeah. If it's clear that you know where the critical points should be, and like I can see that you've figured out, this is the yeah. Oh, you'd never have to do that. Yeah.
63.
So 12, so that's 6. I'm just going to make a note off to the side. I'm just not gonna have room to write 1 pi on 12, 2 pi on 12, 3 pi on 12. So we'll just save time by just saying increments are in pi on 12. Where does our first critical point occur in the x part? Like, what's the x coordinate of our first critical point?
Yes.
Pi on 12. So that would be 1 increment along. And it's at -2. So you'll notice here we're not starting at 0 this time, which is what makes phase shifted ones a bit of a pain. Our next critical point, though, guys, where would it be? +2 in the y direction, but in the x direction? I can't tell if you're talking to me or not because I cannot hear anything. So what's the x-coordinate of our second critical point? 3 pi on 12. So we just go, so at 1 pi on 12, go along 1 to 2 pi on 12, another one to 3 pi on 12, and we've got a peak. So even though our increments are in 3 pi on 12s, we're actually going to be moving along 2 each time. Yeah, that's right. We've gone from a midpoint to a peak. Where's the next one going to be? Back to a midpoint. So 1, 2, midpoint, midpoint. The next one after that second midpoint will be a trough. So go 1, 2 along at a trough. And 1, 2 along, and we'll be back at a midpoint. Now, I'm just going to draw in this part of my curve. Can you see pi on 2, or pi on 12, sorry. 3 pi on 12, 5 pi on 12, 7 pi on 12, 9 pi on 12. So those are the exact coordinates that we figured out before. Like I said, it wants us to plot it all the way to pi on 2. We don't need the coordinates for that because we can just follow the pattern from now. So we'll go across 2 up to a peak, across 2 to a midpoint, across 2 to a trough, across 2 to a midpoint, across 2 to a peak, across 2 to a midpoint, across 2 to a trough. And it doesn't quite make it back up to the midpoint before you get to 2 pi. We do have to bring it back as well to 0. Now, if I asked you where does the third peak occur? If we start, we just got to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 pi on 12. So the third midpoint would be 19 pi on 12. That's it. Obviously the y coordinate would be 2. Now, I know a lot of people have looked at that and said that's so much working out. Did we need to do the full cycle? Did we need to do all the critical points? We could have literally done 2 critical points. We could have done the first one and then the first peak and figured it out from there and then plotted those 2. And we know it's a sine wave. We know it's going to go midpoint peak, midpoint trough, midpoint peak, midpoint trough. As long as you have 2, you're good to go.
Anything.
Absolutely not. No way. As I've said a few times, the only reason I'm doing this is I know students really struggle with the transformations of these functions. I'm just trying to make it as clear as I can why the different changes are happening. Okay, and that 2 questions took us the entire lesson. So tomorrow, guys, we will keep doing these ones. And then we'll do some practice. So we'll be able to spend so tomorrow we'll be able to spend a lot of time with you guys practicing. Oh, that's right. I was going to give you Bow and Bucks for me being late.
7